Alrighty folks, so we're in our last video for section 12.2 and we're going to be looking at limits from calculus. So finding the limit of the difference quotient is an important concept in calculus and will be explained in more detail in the next section. So remember, difference quotients look something like this. So we could have something like f of 3 plus h minus f of 3 all over h. So again, that value, those two values are going to match each other, but if it's not a specific constant, it could be a variable. So in this case, we also could have something that looks like this: f of x plus h minus f of x all over h. And the limit in this case is going to be based off of h, and we want h to approach 0. So we're going to see why in the next section though. But let's see what happens. And we're going to use a specific function for f of x, and we're going to use x squared minus 1. So let's see what we get. Let's start with the first one where we have the constant 3 in there. So let me just first rewrite it. So now we just got to make sure we substitute in everything correctly so we know what f of x is. So let's make sure we plug in our expression correctly. So we want to plug in 3 plus h for x. Everywhere there's an x in our function. So we're going to replace this one, which means we have to replace this one. So if we plug in 3 plus h, we'll use parentheses to be safe. So that should be f of 3 plus h. And now if we subtract f of 3, now I'm going to use square brackets, but you could use parentheses if you want. And we want to just plug in 3, so we know we should get 3 squared minus 1. And that should all be over h. That's the hard part. Now comes the tedious part, which is just simplifying it down very, very carefully. So, and if you do it right, you're going to get a lot of cancellations. So let's break this down a little bit. We can FOIL that out in our heads, right? So 9 plus 6h plus h squared minus 1 minus, and I'm going to distribute that negative into those brackets. So that's going to be a minus 9 and then a plus 1. And that should be all over h. So that gets rid of your parentheses and your brackets. But now look at what happens. So you have the 9s are going to cancel and the 1s are going to cancel. So all you have left is the 6x plus h squared on top. And if you look carefully, you can pull an h out of the top. So if you pull that h out of the top, now you can cancel those out. So be careful. Don't just try to cancel up in here. It's very easy to omit canceling out of that h squared, so be careful. And so now you have the limit as h approaches 0 of 6 plus h. And if you plug in doing direct substitution, your limit is 6. So not too bad when we have a constant in there. It gets a little bit trickier when you have something like this though. So let's just kind of split this down the middle here. And so let's first rewrite. So we want f of x plus h minus f of x all over h. Now, again, be very careful when you substitute here. So again, a lot of students make this very common mistake with this. So they would write something like, okay, well, this is just x squared minus 1 plus h, right? That is a big no-no. You're interpreting this expression wrong. F of x plus h would be this, because now you're just substituting the function in and then tacking h onto the end. So this is not the same thing. So be careful, don't make that mistake. So let's just erase that. So what should it be? So now x plus h replaces x. So you want to put x plus h squared minus 1. And again, I'm going to use those brackets. You could use parentheses, but sometimes you might have a very complicated f of x function. So I like to use the brackets. So if we plug that in and put it all over h, now we can start to get rid of all those brackets and parentheses. So we got to FOIL that out again, so we're going to be very careful. So x squared plus 2xh plus h squared minus 1, and now we can distribute minus x squared plus 1. These types of difference quotients should always have lots of cancellations. Specifically, your original function should always cancel out. If you do all of the brackets and parentheses correctly, it should cancel out. So you can see the x squares are going to cancel and the 1s are going to cancel. It should always happen that way if you do it correctly. So same idea as the previous one. We can see that there is an h left over in the two terms that are left, so we can factor that out. So we got h times 2x plus h all over h, and now those h's can go away. So we got the limit as h approaches 0 of 2x plus h. And again, if you want to put parentheses around it, we didn't do that, but you can, just to be safe. But now when you do direct substitution, h goes away, and all you're left with is 2x. And so that's okay. It's okay to have your variable x in there. Even though the h goes away, x might be left over, so don't just lose it. So that should be your answer for this. So now the million-dollar question is, what do we use this for? Well, you'll see that in section 12.3. So see you soon.